Hi guys, welcome to today's video. This is 2018 paper 1, question 1, just dealing with some really common simultaneous equations as well as a great inequality for practice. So let's get into it. Okay, so here's our question. We're asked to solve the following simultaneous equations. And the method for these questions is always going to be the same. So first of all, we're just going to identify which value will be easiest to eliminate. So in this case, it's made pretty easy for us because y is actually already missing. But usually the things you're going to look for are if you have something that you can immediately take away. So let's say you have on one line 2x and on a different line minus 2x, those equations are going to be easy to use. Or if you can just double an equation to take that away either. So that's usually what you'd look for, but in this case it's made pretty easy for us because y is just going to be the obvious choice here for the first variable to get rid of. So here are the two equations we're going to try and get rid of y from. So in order to do this, we're going to need to multiply the first equation by 2 to get a 6y, and the second equation by minus 3 in order to get a minus 6y. That's the easiest way to do this instead of having fractions involved. So now our new equations are here on the right, and we can just add them together in order to get rid of our y's. So after we add the second equation to the first one, we're going to get that our new equation now we're going to be working with is minus 5x minus 8z is equal to minus 50. And recall that the reason we wanted this equation is so we could use this equation up here in order to get rid of now another variable. So now having called our third equation up here just equation number 3, and this equation over here equation number 4, and rewriting them, we can see that clearly the easiest variable to get rid of here is going to be x. And the easiest way to identify which one to get rid of, in my opinion at least, is when you multiply the coefficient of the first x in the first equation, so in this case 1, and in the second equation 5, the number you get is actually 5, so it's a very low number as opposed to if you did it over here, which would be 24, which is much harder to work with. Well, you want to keep things as simple as possible, and we're going to use x to get rid of, although it doesn't technically matter which one you choose. So now multiplying equation 3 by 5, we're going to get 5x minus 15z is equal to minus 65, and even our other equation number 4 that we found above, just letting that be the same because we don't need to change that. And as you can see, we've got a positive and a negative coefficient, the modulus value of which is both 5, so that makes it possible for us to get rid of x. And we're left with minus 23z is equal to minus 115, which means that after dividing across by minus 23, we get that z is equal to 5. So now we've got the value of z, and it looks correct because it's a nice whole number, although it's not always going to be a whole number, but usually when it is, you can take it that it is correct. So now in order to find the value of x, we're just going to plug back in to equation 3 where we used to have z now equal to 5. And we can easily simplify that down to x is equal to 2, so that's the second value we're looking for. And finally, plugging back in for x and z in equation 1, we will find that y is equal to minus 1. So there's our third value. So now we found the value of x, y, and z, which is the entire goal of this question. And you'll find that with the simultaneous equations, especially when there's 3 variables, there will be quite a lot of writing and changing around equations, but it's always going to be the same really, just with different numbers, which always makes it a reliable thing to be able to learn off and do well on. And for this particular part A, on this question 1, you would have got 15 marks for getting out your 3 variables. So now in part B, we're asked to solve the inequality 2x minus 3 over x plus 2 is greater than or equal to 3, where x is a real number and x is not equal to minus 2. And just to quickly illustrate why x isn't equal to minus 2, because many people don't actually know why that is. If you plug in minus 2, the bottom line will cancel to be equal to 0, and any value of x which makes the bottom line cancel to 0 will always be invalid. So the approach to these inequalities with an x on the bottom line will always be the same, and that is to multiply across on both sides by whatever's on the bottom line to be squared. The reason we can't multiply across by x plus 2 is because we don't actually know whether or not x is a positive or negative number, and if, for example, x was a negative number and it exceeded the value of minus 2, then you would actually be multiplying across the whole inequality by a negative number, which would flip the sign. So it actually interferes with the inequality itself when you multiply across by a negative number. So I hope that makes sense. Long story short, you don't multiply across by what's on the bottom line, you just multiply across by what's on the bottom line squared to ensure that it's positive. So once I do that, we're going to get this now much easier to rearrange inequality, which can be further simplified to this by just expanding out our brackets a bit. And once again, by simplifying further, we can turn it into this inequality that has no brackets now, and this was actually supposed to be an x squared up here. So that's one thing that I just forgot to write there initially, but after multiplying in, we just need to get everything to one side of the inequality. So in my opinion, it's easier to just bring everything across to this side of the equation. So minus 2x squared plus 3x minus 4x plus 6 across. And we're left with this nice quadratic, x squared plus 11x plus 18. So now we just need to look for factors of 18, which add up to 11. And of course, those are 9 and 2. So we can now factorize our quadratic. And we're left with x plus 2, all multiplied by x plus 9, is less than or equal to 0. So the easiest way to go about this is just to draw a graph in order to see the quadratic we're dealing with, and just sketching it to see what part of it is in between minus 9 and minus 2 and which part is beneath the x-axis. And they do actually quite like when people draw graphs for these type of questions involving inequalities, because it is in the marking scheme, and although it's not required to get full marks, as far as I know, it is actually preferred if you do have this in the question. So our final step is going to be to pick any number between minus 9 and minus 2 and see if it works in the original inequality. So if this inequality is true, I've just chosen minus 5, any number at random will do. So is minus 10 minus 3, which is equal to minus 13, over minus 3, greater than or equal to 3, so 13 over 3. So is 13 over 3 greater than or equal to 3? We can multiply across by 3 and find that our inequality is 13 greater than 9, which it actually obviously is. So therefore the values in between minus 9 and minus 2 work. And therefore our range is x is greater than or equal to minus 9 and less than minus 2. And again, be very careful with this part of the inequality here being less than minus 2, because we are told it's not equal to minus 2, because that obviously doesn't work. So it's less than minus 2 rather than less than or equal to. But that's all you're expected to do in this question, is identify the range. Remember that it's not equal to minus 2, and be seen to test it to make sure that it's right. So our range of values is just in this interval in here. And for doing part B out and getting your inequality out and everything, you're going to get 10 marks. And that's actually it for this question. So I hope you enjoyed the video. If you did, there's going to be other similar videos in the description, as well as some other helpful resources if you're finding something like this a little bit more difficult. And I'll see you next time.